Okay, year 12, we're looking at normal distribution number 2, and this is, excuse me, when we don't have integer values, so when we don't have plus and minus 1, 2, and 3. But just to remind you, we've got, when we've got plus or minus 1, we have 65%. When we have plus or minus 2, we have 95, and we have plus or minus 3, 99.7. Okay, so the Z-score formula I've typed up here, but what it looks like is down here. So you take the score minus the average, so X bar is the average. Oh, I'll get it over here, sorry. X bar is the average, and standard deviation, SD, okay, is the Greek letter lambda. Okay, it's like a circle with a head on it. Okay, so that's the formula. Copy that and come across when you're ready. Okay, so let's have a look at some Z-scores for a person who scored 50% or 87%. So we're just calculating Z-scores, okay? The average is 65 and the standard deviation 12. Just use that formula and see how you go. Come back when you're ready. Okay, so we're back. So the first one is 50 minus 65 over 12, which is minus 15 over 12, not positive 15. So it's minus 1.25, okay, to 2 decimal places. Next one is above average, so it's 87 minus 65 over 12, which is 22 over 12. And on my calculator, 22 divided by 12, 1.83 to 2 decimal places. So we're just doing Z-scores, that's how you calculate them. Don't forget to press equals before dividing. Okay, coming across. So, on the tables that you've been given, you've got numbers. So, down this column here is to 1 decimal place, and then the next number, the second decimal place, is across the top. So, it's areas behind the Z-score, okay? So, for instance, as I've got here, if I've got, the previous one was minus 1.25, okay, so I've got 1056, so that means that 10.5% are behind that score, or 100 minus 10.56 is 89 ahead. Okay, so let's have a look at the next one. So the next one was 1.83, so I go to the 1.8 column and then I come across to the 3 column to get 1.83, and so I get that 9664. So 96% of kids are behind you and 3.3% ahead of you. Okay. So in some textbooks and some worksheets, they have a notation for normal distribution. Okay, so if you see, okay, X squiggly line N, okay, X represents the scores and follows a normal distribution. For the other distributions, they got different letters, and then they put 2 numbers in a bracket. They got the first number is the mean, but the second number is not the standard deviation. It's actually called, this second number is called the variance. The second number is the variance, and so you square root it. The standard deviation is the square root of the variance. Okay, so just be careful when you see questions where you've just got no words, you can actually still do it. Okay, copy that and come across. Okay, so what do you do when you have scores between certain numbers? So in those previous examples, I had 10.56. Okay, so I've got, so I had 10.56 behind, and then the next one I had behind, I had 96.64. So to get in between, you just have to subtract. So if I want to have a score in between 2 numbers, I just subtract the 2 areas, and that'll give me the area in between. And once you know the percentage, if you know the number of students who did the test, you just do the percentage times the number, and that would give you the expected number, either behind or in between. Okay, so as long as you know the total and the percentage, you can use those numbers to find the expected value. So copy that and come across. And, okay, so in a test where the average was 65 and the standard deviation was 12, there was 30 people, how many people score between 60 and 90? So we'll do this one together. Okay, so the first one is 60 minus 65 over 12. That's the first Z-score, and this will be the second Z-score. So I've got minus 5 over 12, and you just need to do that to a couple of different places. So that's minus 4.42, and the next one is 35, not 30, 25. Yeah, 25 over 12, and that equals, calculator says 2.08. Now on the tables, area behind Z equals minus 0.42, so I'm getting my table out. Minus 0.42 is 3372. And area behind the second Z-score, which was 2.08. Okay, so turn the page to positives, 2.08 right across the other side, 9812. So the percentage in between those, 0.9812 minus 0.3372. So in between would be 0.6440, and there were 30 people, so the expected number would be 0.6440 times 30 people times 30, so I'd expect 19.32, which is about 19 people. Okay. So copy that and come across when you're ready. Okay, so another advantage with Z-scores is you can actually use it to rescale. So one student scored 60% in a test with an average of 51 and standard deviation of 12, and the teacher said that the average was too low, so I'm going to rescale it to an average of 65 and a standard deviation of 10. So this is what's happening. The Z-score is 60 minus 51 over 12, which is 9 over 12, which is 0.75. Okay. Now, when you rescale, Z-score doesn't change. Okay, that's all you're doing is changing what the score is. You're not changing the Z-score. So, in the rescale, 0.75 equals the new score minus the average, and the average is 65, divided by a standard deviation of 10. And then you just rearrange the formula. So cross multiply, so 7.5 equals new score minus 65, and then just add 65 to both sides. So 65 plus is 72.5. So that's the new score. Okay, so the Z-score never changes for rescaling. All you're doing is changing the score that went with it. Okay, so copy that and come across when you're ready. Okay, so this last one, in a normal distribution with a standard deviation of 2, the probability the score selected at random exceeds 25 is 0.05. Find the mean and find a score for which 80% of the scores lie above, sorry. Okay, so let's have a look at what the diagram looks like so we don't get too confused. Okay, so we don't know the mean. Okay, so the probability the score selected at random exceeds 25 is 0.05. So that's a small, okay, so exceeding is above. So we've got a small area. So there's some score that the area is 0.05. Okay, so because it exceeds 25, the area is 0.05, which means that the area behind is 0.95. Okay, so in your table, you need to find an area that's close to 0.95, and the closest one, I got 9495 and 9505. So I'm going to split the difference. So at 1.95, At 1.64, I've got 0.9495. At 1.65, I've got 0.9505. I know what 95 exactly, so I reckon that means you want 1.645 Z-score. Okay, so I'm using the table backwards. Okay, so 1.645. I forgot to put in the diagram that score is actually 25. Okay, so the score is 25. So I've got 1.645 equals the score minus the average, which I don't know, divided by a standard deviation, which is 2. And then it's just double the number, 1.645. 1.645 times 2. So I've got 3.29 equals 25 minus x bar, and then just swap the positions. That goes forward, that comes back. So 25 minus 3.29. So the average is 21.71. Okay, so we've done that question, and then find the score for which, that's part A, and part B, find the score for which 80% of the scores lie above. So I want 80% of scores to be there, so I need 20% of scores to be back. Okay, and I don't know what the score is. Okay, so what we look at is what the Z-score is. Okay, so for point 2, closest number is negative 0.84. So, excuse me, negative 8.84 equals the score that we're trying to find minus the average over the standard deviation, and then just multiply by 2. 184 times 2, so minus 1.68 equals x minus 21.71, and then add that to that side. Minus 71. So you end up with, oh, there goes the bell. So that score is 20.03. Okay, so copy that, come across when you're ready, and that's the last page. So hopefully you've got something out. There'll be worksheets on Moodle. Okay, bye.